Hello, we will learn random forest for this session. So let's go to Google Colab, colab.research.google.com/create equal new. Good. And then our goal. Okay, so let's add the text. Actually, save the file name. So random forest Python class. Okay, and then for text, um, our goal is to predict temperature, tomorrow's temperature, conditional on historical data. So we will use the data, the maximum temperature data, the data about maximum temperature, data of maximum temperature in Seattle, okay, in Seattle, and Seattle, and then the data are from the National Oceanic and National Oceanic and atmospheric administration, administrations NOAA data. And this organizations is called NOAA. Okay, so NOAA data. So, well, the data website is basically HTTP, I think, .ca search NOAA data. Okay, NOAA data. So climate data. Yeah, so basically this one. Yeah, climate data site. So yeah, data access data service API. Yeah, here. And then in particular, our data is from this one. Climate data online. Okay, so let's copy this website and paste over here. Okay, so this is our data source. Okay, so our goal is to predict tomorrow's temperature, tomorrow's maximum temperature, actually, daily maximum temperature, conditional on the historical data. We will use the data about maximum temperature in Seattle, the data from the NOAA. Okay, good, so far so good. And then we have to acquire the data. And then let's move this on up. In order to acquire the data, first, actually, I save the data at the CSV file at the Google Drive. So first, let me import pandas as PD. Okay, run it. And then actually I have a URL. Let me copy URL from the other browser. So we will import CSV data from a Google Drive. So this is URL. So URL equals this one. Okay. So it's a public URL for Google Drive, which is also the CSV file actually. And actually we have to define also path. Path is, it is Google Drive, google.com, Google Drive, and then export. We have to export the data, and then we export the data by download, and then we specify ID equals, okay, equals, and then we can put URL over here. Okay, URL, and then actually we have to add URL, and then we have to split the URL with slash, of course. Slash, because it is the address. And then let me see. Okay, and then features is basically PD. Now read CSV file. I'll read the CSV file and then make it pandas data frame, and then data is at the path. Let me see. Okay, not bad. Let's see whether data are correct. Features header. Print features header. Okay, so we have this data. Let me print the tail. Okay, something like that. So we have some data here. And then I think we need explanation about the data. So instead of print, let's see everything, every item. Okay, so we have year, month, day, week, temp 2, temp 1, average, actual, forecast, NOAA forecast, and the ACC forecast, and the forecast under, and then friend forecast. Friend forecast noise. So it slightly needs some explanation. So year, basically, because we have only, we use only year 2016 data to predict year 17 temperature. Okay, and then next it is month. So month is of course months of the year. The year, and then day is of course day of the month. Right? It is straightforward. And then we have week. Week is of course day of the weekday. Weekdays. And then it is actually character string. This is a character string, right? And then we have temp 2. Temp 2 is the what? Can you guess that? It is the 2-day prior max temperature. So obviously to predict today's temperature, we want to use temperature 2 days before. Of course, we want to use temperature of the yesterday. Temp 1, it is the 1 day prior, 1 day prior max temperature. Okay, and then average. And then of course we can use, like, if we want to know the today's max temperature, we want to know what was the average temperature for the historical average temperature for today. Okay, so we want to use that. So it is the historical average max temperature, right? And the actual is of course actual temperature. And then we have a friend. Right? Friend is your friend's prediction. In fact, it is a random number, right? Between 20, yeah, between average minus 20 and average plus 20. Okay, we have average. So it's a random number over there. Okay, so we specify the data. And then let's figure out the shape of the data. Print shape of the data. What is the size of the data? The shape of our features data is, and then we can print out features, and then we want to see the shape. So, and then see. So what we have, our data point is 348 observations, and we have 12 columns. We have 12 columns. Good. And then let's see the summary statistics, descriptive statistics of each column. And then see the descriptive statistics for each feature. And then we can just simply, that is very good in pandas library. We have very good function called describe, and then feature describe, and then it describes the features. Okay, so it has, for each features we have count. Count is always 348, and the mean, standard deviation, minimum value, 25% quartile, 50% quartile, which is median, 75% quartile, and max. Okay, so yeah, you can look at this. So data looks fine. Actually, I can print. If I print it, I can see only partially. Okay, but it is clean, huh? Okay. And then what next? We described, and then we have now years, months, and then days. So we want to merge them. Okay, we want to merge them. So we want to use date time, use date time to handle the date. Okay, handle the dates. Let's do that. So import date time, import date time, and then we have years, months, and days. Years and months and days. And years is in the features. We have what? We have data called year. And then we have data for months, column months, entry, and then day. Okay, years, features. Actually, we need S. Good. And then we want to combine. We want list and then convert to date time object. How to do that? Well, simply we can define dates. We can define date, and then we can connect them like string, and then we combine string and then year is integer, and then plus, right? And then we want to put hyphen, and then plus string. Now integer of the months. Okay, here months, and then plus string, and then what? String, and then integer day. Okay, integer day. Okay, and then of course they are not yet defined for. Okay, therefore year and months and day, year, months, and day in what? They are in the, let's zip, and then they are in the our data set we just defined, years, and then months, and then days. Okay, and then we check the days. Okay, now well we connect them. Okay, and then we want make it to datetime object. So dates equal, again, we can make it datetime, and then yeah, we can do strip time, and then we have a date data. We'll go to date, and then the format is we just use hyphen between year, month, and date. So year, right? Year, month, date. Okay, and then we have to define date, and date is in days. Of course, we need a full date in days. Invalid index for date index. So we don't need a comma over here, and that looks fine. Okay. So I think we finished preparing the data at this point.